We're going to look at combinations in this section. A combination is a selection of objects, where we disregard the order of selection. It is slightly different from permutation, which we will contrast it later on. Let's say, for example, I want to pick 3 letters from 5 letters, A, B, C, D, E. One example is, okay, I could have a set A, B, D. I could have a set B, C, E. But how many possible different selections can I have? That's the question. Now, these two are considered a different set because obviously, for obvious reasons, this one has got A, B, and D. This one hasn't got A and has got C, for example. So, no problem. Now, more importantly, we do not count these two, this one and this one, as different selections because now when we talk about combinations, we are disregarding the order. So, do not count them. We won't count them as different. They are the same. To us, it's a basket, and that's it. ABD means ABD. I select A, B, and D. I don't care about the order. So the question then becomes, how many can I have? How many different combinations? Basically, how many ways can I pick 3 letters? All right, ignoring the order. But we have learned how can we arrange 3 out of 5 letters. Am I right? We have done that before, which is permutations. I beg your pardon. So this is for each combination ABD. I could have ABD, ADB, BAD, DBA, blah 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 blah. This essentially is 3 factorial ways. Am I right? 3 factorial ways. For each another combination, you have another 3 factorial ways, which is all this. For another combination, we have 3 factorial ways. Now we actually. This is what I'm saying. Each combination gives us 3 factorial ways. Which means the number of combinations here multiplied by 3 factorial, because the number of combinations, each combination has got 3 factorial. Yes? Will give you the total number of permutations, and we have learned this earlier. This is what we learned earlier. We learned this earlier. How many ways can I arrange 3 letters out of 5 letters? This is 5p3. So, is it obvious to us that therefore the total number of combinations here is just 5p3 divided by 3 factorial? Get it? So, this is a specific example. Let us use generic terms to define this now. So, the number of ways of selecting R objects out of n. Example, just now we gave the example, we want to select what n was 5, correct? Your R was 3, correct? We denote this by NCR. How do I find NCR? Later I come to it. But just now we use this example, number of ways of selecting 3 out of 5 was given. We denote it by 5C3. And 5C3, as we have shown earlier, is actually you permute first, then you divide by 3 factorial. We have seen it earlier. So, therefore, this NPR can be seen as first I choose R is example 3, N is example 5. Alright, I choose 3 out of 5 first. Then after that, I multiply by R factorial. So this formula works like that. So we already learned the definition of this. We learned this earlier. Then what is then the definition of NCR? If you refer to the notes, your NPR was defined earlier, right? Your NPR was defined as this. Then you divide by R factorial, you actually get this formula over here. This formula is actually nothing new. Why? Because you have learned it in binomial theorem. This one is actually given in the formula list. This is given in MF 27. And this NCR is the same NCR that we used for binomial. But It's just that in probability, in P&C, we are using this in this context. Number of ways that I can choose R objects out of N objects. Some useful result. NCR is NCN minus R. Let's be a bit more concrete. Basically, what we are saying is 5 choose 3 is the same as 5 choose 2. Right? What we are saying is, how many ways can I choose 3? These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways. Now, the same 10 ways is, you can look at it as, if I choose 3, I leave behind 2. Correct? I leave behind 2. So the number of ways of choosing 3 is the same as the number of ways I choose 2. Because when I choose 3, I leave behind 2. Simple as that. So just remember this idea. This one is very useful to visualize it. A few more special cases which I don't want to dwell on too much, because NCN means how many ways can I choose, say for example 5 objects, a basket of 5 out of 5. Of course it's only one way lah. A, B, C, D, E, there's only one set. How many ways can I choose 0? Choose 0, one way lor. Choose nothing lor. Cannot choose. That means it's 1. Correct? Yeah. So that's that.